Hi there, it's Professor Monte, and we're talking about solving radical equations that have two radicals. Now, I made another video in solving radical equations with one radical. You may want to refer to that if you need to before you watch this video. I've linked it at the end of this video, so if you need more help, you may want to go look at that. Okay, here's what we're going to do here. This is an example of one with two radicals. Now, the idea is I'm going to isolate one radical. I'd like to square both sides and get rid of both radicals at the same time, but you can't distribute a square or an exponent across addition or subtraction. So I can't just square each of these individually. I'd have to FOIL it out, and I still would, my middle term would have the radical. So I'm going to isolate or get one of the radicals all by itself. Then I'm going to square both sides to get rid of one of the radicals. And then I have to isolate the other radical, square both sides again, that'll get rid of the second radical. Then from there I can solve. Now, remember, anytime we square both sides, we may run into an extraneous solution, meaning we didn't do anything wrong, the solution just doesn't check in the original problem. So any answers I get, potential answers, I need to put it back in the original equation, see if it gives me a true statement. If it does, it's an answer. If it doesn't, it's extraneous. I have to throw it out. All right, let's get started. Now, these are going to take up a little room, so I'm going to kind of not show every step, but I'll tell you what I'm doing. So first, I want to get one of the radicals all by itself. I like to get the more complicated one by itself and then square it. So I'm going to subtract this x square root of x plus 2 on both sides. So I'm going to have this square root of 3x plus 4. But it's going to equal 2. So I subtract this or just move it over and change the sign, however you like to do that. And it looks like that. Now I can square both sides. Squaring both sides will get rid of that radical, but this one will still be there because I have to FOIL that out. So let's square both sides. And if you remember the square formula, it's going to help a lot. But this square just eliminates that square root. I get this. But over here, I'm actually going to have to FOIL this out. Okay, and again, if you remember how to use the square property when I have terms, go ahead and use that. But I'll just FOIL it out. So I've got 3x plus 4 over here. I'm going to get 4 minus 2 of these square roots minus another 2 of those square roots. And then the negative times the negative is positive. The square root of x plus 2 times the square root of x plus 2 is the square root of x plus 2 squared. So the square gets rid of the square root. I just get the x plus 2. All right, combining like terms. So I'm going to combine these and these and these. Well, I don't really combine them all, but you'll see what I mean. So I get x, the 4 plus 2 is 6. So x plus 6, and then minus 4 of these. All right, so I got rid of one of the radicals. Now I'm going to isolate this one and square both sides again. So let's do the minus x minus 6. So I get 2x plus 2x minus 2 rather equals negative 4 and then the square root of x plus 2. Now, sometimes if I divide both sides by the negative 4, it goes into these evenly, and you may want to do that. You don't need to, because when they're multiplied together, I can just square both sides, and it squares each piece individually. So I can do that with multiplication. I just can't do that with addition or subtraction. So now I square both sides. So this side, (2x minus 2 times 2x minus 2). Hopefully you know how to FOIL that out. I'm going to FOIL that. I'll just put what it comes down to. But this, I square the negative 4, I get 16. I square the x plus 2 square root, I just get x plus 2 without the square root. And now when I FOIL this out, so I'm going to FOIL, and I'm going to get 2x times 2x is 4x squared. Negative 2 times 2x is negative 4x, but then I get another negative 4x, so negative 8x. And then negative 2 times negative 2 is plus 4. Equals, and here I'll just distribute 16x plus 32. Okay, so I just FOILed that out. All right, now I have an x squared and an x, so I need to set it equal to 0 so I can factor. So I'll subtract the 16x minus 32. I get 4x squared minus 24x minus 28 equals 0. And you can divide both sides by 4, because 4 goes into all these evenly, or just factor it out. I'll show it with factoring it out. X squared minus, let's see, what's that going to be? 6x minus 7 equals 0. Well, that factor, I'll move it up here so we can see what I'm doing. So I get 4. That factors into x minus 7, x plus 1 equals 0. And remember, you said each of those equals 0. Well, 4 doesn't equal 0. X minus 7 equals 0 when x is 7. And then x equals negative 1 by subtracting 1 from both sides. These are my potential answers. Remember, I have to check back in the original equation. I don't have a lot of room to check it, but let's do a quick check. Check x equals 7. So I'm going to do a lot of the work in my head. Notice if I plug in a 7 there, I get 7 plus 2 is 9. The square root of 9 is 3. Plus, plug in a 7 here. 3 times 7 is 21. Plus 4 is 25. The square root of 25 is 5. And so then I get 3 plus 5 equals 2. But that's 8 equals 2, which doesn't work. So 7 is an extraneous solution. I can't use it. Let's check 1. Check x equals negative 1. If it works, that's my only answer. If it doesn't, no solution. So I plug it in. Negative 1 plus 2 is 1. Square root of 1 is 1. Plus 3 times negative 1 is negative 3. Plus 4 is 1. Square root of 1 is 1. And it says it equals 2. This time I do get a true equation. So that is an answer. I get to keep the x equals negative 1. 7 was extraneous. I had to throw it out. Negative 1 works, so I keep that as my only solution. So that's where you have to be careful. So the big things students often mess up on is, one, they forget to isolate a radical. They think they can just square from here and get rid of both radicals. Or sometimes they'll do this, and then they think they get rid of that radical also anyway. You have to square both sides twice to get rid of the 2 square roots. And then make sure you check your solutions and throw out any extraneous solutions. All right. Hope that helps, and we'll talk again next time.